I'm really not that experienced in doing streams. Maybe this should be like a proper one, the first one. So yeah, and I also should be taking a look at the video so that I would know if you guys are able to see the screen properly or not, because that would be a problem if you wouldn't be able to see anything that I do here. So in a way, I have to open screens somewhere. Okay. Now I think you guys can see the screen just fine. Now let's go through the process here. And maybe let's give a simple introduction here. So, hello, my name is Binod, and I've been trying to do the system programming language like um, C, Rust, and all of these thing. I started with Rust, giving me idea what all the things that I should know about. And I also tried like C a little bit of it at least. So, you know, okay. So let's open this. Oh, okay. So this is just a simple normal program, and I didn't do much up here. So I think I just created a linked list and using all that malloc and dynamic allocation of memory and all of that. And I had to learn like CMake to build the stuff, and using the higher level language you really don't have to know all of this stuff. And so going back to the roots, I suppose, because C literally is used in every major languages. The compilers that is written with LLVM, that all are written in C++. I mean, C++ is just an abstraction that is used to let the programmer not mess up with the memory like what Rust does, but maybe a little bit complex or not. I I'm not sure about that because I haven't tried that a lot. But anyways, um, we are getting out of topic here. We should start with jig here. Okay. Um. So I hope you know what is jig. You know. Um. So it is like somewhere in middle of C and Rust, and I've used Rust a lot more than I've used C, but I think I have a general understanding of both of them. Um, so more or less, C is like a direct abstraction to the assembly language, but Rust provides you with safety so that you do not mess up. And we are just human and we make mistakes, and we do not free the memory that we used. So, best idea would be to just have a process and make the programmer go through the process. Um, and sometimes the rigidity really makes the process very difficult. And I don't know if I really like that I'm not really a fan of getting used to some rigid framework. And I'm not like some guy who does testing all the time. I don't like that, but I would prefer more testing rather than just getting used to some rigid um, um, compilation process that you have to go through and make sure that it handles that. Okay, so let's get to the jig here. Okay, now, so where did I? Okay, so this is getting started page. Now in jiglang.org, we should be able to see, yeah, you can just click here and I hope you have already installed the jig compiler. So I'm using this WSL web sorry, uh, this is Linux that I'm using in Windows. Um, so I have a very bad memory. So, okay. So I just forgot the full form of WSL. So, uh, WSL means Windows Subsystem for Linux, and I know all of you know that, and I feel stupid to even forget that. But still, if you are using Windows, you can just go here and the process is very easy. You can follow through it, and yeah, you can just choose any of this stuff. And but for now, I'm using Jig in Linux, and okay, um, I didn't really build it from the source, but you can just use okay. I should be able to see this is Windows. This is Mac OS and this is Linux. Mm, I think I have the latest version, version 0.12, but I think you have already installed it, and I don't really have to go through the whole process of telling you what to do. Uh, oh, so you already have version 13, but anyways, you do you, and just install it. And so this is the tar.xg file format, so you can just decompress the binary or all the files inside it, and put that in binary folder or anything, or you could just add to the .basrc export file. um, I think you can just do that. Okay, let's now get to the programming stuff, because we have already talked a lot of nonsense here, and I do not want to waste your time any longer. Okay, so um, so let's create a jig project. Jig, uh, YouTube, learn. Yeah, learn one maybe. Sorry. Um, Okay, now let's go through the process together, maybe. And I know there is no views right now, but I hope somebody watches this. I mean, I could only hope. Anyways, um, let's go and initialize the jig project. Okay, so we initialized it. Okay, so what is saying? So we have like main.jig file and build jig John. This is the build system of jig, and we have root.jig. I am not really sure what this file is for, but we'll see, I suppose. Okay, and it is saying that if we run the command jig build run, then it should compile and run the program. So let's do that. Jig run. So it is going through LLVM. And let's just say, yeah, all your code bases are belong to us. And um, I think so. We are in the main file of the source directory. If you didn't catch that, so this is the main function pub. So it certainly should mean that is it is public. Um, and this sign, I suppose we will get to discuss this in this stream, maybe. No. Standard debug print. Maybe let's comment this out. Okay, standard file. So at the top we have standard equals to at the rate import std. So that should mean that this is the um uh, do we say the standard library? Yeah. So all the stuff that the compiler provides by default. Um and I don't really know what this line means, but I guess we will see. Anyways, let's just sorry, clean up the whole. Maybe let's just delete this too. Let's start from a clean slate, I suppose. Again, now we have gone through the getting started process, but I think we should go through so our version is 0.12. I think this is the default one for now. And if you are not selected in this um, point, then maybe you should. I think the API of the language is different according to the version, and probably as we don't really have a 1.0 version, so I don't think all the changes are um, you know non-breaking. I think they are breaking because I have used a little bit of it. I think I should say to build my C project using build system of jig for C code, but it didn't really work out because The changes had been made a lot, so I was more confused than anything. So maybe we shouldn't do that for now. Maybe we should wait for maybe 1.0 version. I don't know. It's your choice. Okay, so get to this page, you need to click the documentation page here, and you should select this one. Okay, so yeah, maybe I don't know. Let's read from the starting. Jig is a general purpose programming language and toolchain for maintaining robust, optimal, and reusable software. And I think uh, everybody should focus on what Jig language is really for. So and I think where it distinguishes it from maybe Rust. Okay, so I think this should be a more important one, but let's read from the top. So I think we have already read this one. So let's read this. A simple language. Focus on debugging your code rather than debugging your programming language knowledge. So I think this is a direct hit to the Rust because when you are starting with Rust, so you get all of this knowledge at once. You don't know what to do. You have to understand about borrowing and what is ownership, and as you go on with it, as you get good enough with it, then again you will be hit with lifetimes, phantom data, and whatnot. Self-referential data, and you need to know how the drop drop checker works, and you need to know the covariance, invariant, and all of the stuff. Uh, and this is really uh, get out that really gets out of hand, and it really gets complicated, and you have to understand about the macros, and that doesn't even really use the standard language. You have to understand some syntax like regular expression, and that is just not it, for me at least. Okay, so focus on debugging your application rather than debugging your programming language knowledge. No hidden control flow. So, in other languages, maybe they are doing something behind the scene. I mean, every language will do something behind the scene, but you will know what it is doing, and no hidden memory allocations. You will know when all the memory allocations are done. So there are systems in place, like different allocators that you can use in Jig language, as I have heard, I should say, because I haven't really used the language a lot, or even sufficient enough to know that. Um, so yeah, and no preprocessor or no macros, but we have something like com time. So maybe this will get in handy. But let's not just get into the definition and stick there. Let's write some real code that runs. Okay, now. So we are in the introduction page. So this is the Jiggy standard library. Okay. So let's read through it. Jig standard library contains commonly used algorithm, data structures, and definition to help you build programs or libraries. You will see many examples of Jig's standard library used in this documentation. To learn more about Jig standard library, visit the link above. Yeah. So we have our standard library, and so we have a variable const, and we have std standard input output, get standard out dot writer. Then we have try standard out dot print hello, and this should be our variable, but I think this should mean string, but maybe we are just um skipping some parts because as a programmer, new to a language, we are not supposed to know what all the APIs written in the language should mean. um I mean, that is really not how it goes. You don't even know how the language uses puts or print or console log. We are not supposed to know that. Maybe documentation could be a little better or in that progression. Okay. Now maybe this is a little bit um easier to understand. So we have something like we imported print and we use the standard library dot debug dot print. um okay, let's start from there. But how is it using up here? Standard dot debug dot print. Yeah, that is better. um let's start from here. Okay, so I think you already have this line in your code. No, importing the standard library. And now um let's do something like standard dot uh debug dot print. Are we supposed to have something like that? Print, and then argument, it says, do we have something up here? Another comment, an argument. Okay, we don't really have any arguments, but I guess we are supposed to give this empty argument. I really think that the documentation should follow some kind of uh, pattern, maybe starting from the simpler things, but we can also see from the example above that we have given something like a hello, and here is the string. Yes, I think that should mean that. Um, anyways, let's say hello. Let's say hello there, and okay. Mm, 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 mm. Let's delete this. Okay, so let's just follow what the language is telling us to do, and maybe we'll be just fine. Jig, build, run. It didn't really do anything. Did we mess up something? I don't know right now. Standard debug print. Okay. Okay, so that was kind of a crazy bug, maybe, you know, if we don't really give a next line marking here, then it wasn't showing the print line. So, so maybe let's even check the variable stuff here, the string one. I don't know what this means, the bang, but we are here to try anyways. Okay, let's try hello. Um, hello again. Sorry. And I don't know if this really is like as for just string or just giving some kind of uh again two, and we are just trying to learn here. So yeah, it just works fine. Hello again and but does it really mean yes or just we can give anything like I don't know I'm really not sure. Yeah. So I suppose um it really means yes, that is string. Okay. So we are clear about something. So let's try um something different. Mm, mm, mm. Values dot jig. Okay, maybe we should not go from the introduction because it is skipping all kinds of stuff here. Um, I don't think we should do that. Um, okay, maybe let's start from Jig Standard Library. I think that would help a lot because as we are going through the introduction, I think everything is included in a file. Suppose it is I think it is assuming that we should know more or less the simplest part of the language or the basics of it, but we are just trying to learn through it, which doesn't really help us a lot, you know. Um, okay. So we have already done this, but we don't really know what the bang means. Okay. So, anyways, let's go through it. And sorry. So, you know the comments thing, so I don't think I really need to tell you that. Okay, doc comments. A doc comment is one that begins with exactly three slashes botnet 4. Multiple doc comments in a row are merged together to form a multiple doc comment. The doc comment documents whatever immediately follows it. I think this is more like the stuff in Python that is called the docstring one, just to document what the function is doing or whatever the you know the elements are doing, like the struct here. Maybe let's go through the hello world. We do not want to get uh over ourselves at the very first tutorial or maybe learning process to learn the language, because we need to find some kind of a linear way to go through it. Yeah. So we have comments, and there is that. Let's talk comment, top level comments. What is the top level doc comments? Top level doc comments is one that begins with two slashes and an exclamation point. It documents the current module. It is a compile time error if a top level document is not placed at the start of a container before an expression. Okay, values now. I suppose the whole document goes through it as it follows the progression here on the left side. Okay, so we have values. So it says top level declarations are order independent. So we have assert, debugged assert. Um, we have I32 type, that is integer. It should be signed because you would be unsigned, but I don't know if it follows the same progressions or the same taxonomy as other languages. Okay, so we have two. We're doing this, and we don't really need to give anything up here. Just curly brace. That is something. True, false. We have ops now, so okay. So this might be a better start up here. So let's talk about the types. So in the left side, we can see like we have primitive types, primitive values, and all this stuff. Maybe just let's just start up here, and we will go through all of those stuff one by one. Okay, so we have I8, that is integer 8, T, signed 8-bit integer. So yeah, it also follows the taxonomy as C and Rust. So we have I8, that means 8-bit integer, and I think you should know how to calculate the range up here. Maybe I will open, so 2 power 8. So that would be 256. Or if you don't even believe this, maybe Google calculator. Okay, no, no. But I suppose you could believe this, and maybe some of you even know this at the top of your head, that 2 powers 8 means 256. And so the total combinations, that means the total combinations are 256, but as it is signed 8-bit integer, that means we have to assume that the values could be negative or positive. And the normal progressions, maybe I don't really want to use pens, maybe sketch.io, maybe, I don't know. Mm. Pencil, yeah, it's just fine. So we have a progression here. Huh? So from here to here, we have like 256 combination, and I apologize for my handwriting, but you need to understand that I'm using a mouse pad for that. Maybe I should use a mouse. I will use a mouse. Okay, let me connect the mouse. I'm using writing. Sketchpad would be much better, but we have to use what we have here. Mm. Okay, so we have 256 from here to here. So we need to understand that the numbers could be, you know, positive from here to here, positive, and from, sorry, here to here it would be negative. Everybody knows that. And it may be a bit jarring for people who know a lot more than this, but maybe stick with it for now, because some people might not know that. And so we generally go with the route of two's complement, and two's complement complement. I don't really know the spelling, but I suppose you could search somewhere in the web. So this is two's complement. So that divides the whole chunk of 256 into positive and negative. So you can assume that the negative part is half of 256, and positive part it is part of um, half of 256. But the thing is, the normally the um, range would be something like, what should it be? So it should be 2n, n would be the power, and divide by 2, This should be the negative part, and positive part would be 2n divided by 2 minus 1, because we already have a 0 part here, and we also need to assume that we need to you know um, take that into consideration, as we have 8 bits. So 1 2 3 4 5 6 7 8 bits. So this would consider a 0. Now as we move on through it, and maybe a tidbit, you know, to help you understand this, and maybe sometimes when you see the binary format of this stuff, that you could just figure out whether the digit is positive or negative. So just look at the last bit here. So this would be the sign bit, SIGN. This should be a sign bit, So if this is 0, 0 means positive. If this is 1, that means it's a negative number. So I think this is enough for the discussion. Okay, yeah. So this is 8-bit signed integer. U8 means unsigned 8-bit integer. That means it takes the whole 256 um, part with it. So the range would be like from 0 to 255. And we have I16. So instead of 8 bits, we have now 16 bits. So this is a signed bit. Just understand that I means signed and U means unsigned. So unsigned starts from U, so that we can remember just that. U means unsigned, and the part beside the alphabetical letter is the bit. So after that we have the same kind of thing with 32-bit, 64-bit, 122-bit, and now we go to I size. What does this mean? Um, int pointer t signed pointer sized integer. So signed pointer, unsigned pointer sized. Sorry. Maybe I'm confused with this one, signed pointer and sized integer. So u size should mean that what is the size of your register. Maybe your machine is a 32 or 62, 64 bit. You, Most probably it's a 64 bit. Then it should be a 64 bit size, but yeah, I think the thing is doing it just that, but we don't really know whether the size of the machine is 32 or 64. I think it just gets it while it compiles, gets the information from your um, system. I mean, in Rust, you use usize for the size of your machine architecture. So that should mean the same, but maybe we'll get to it later. And you don't have to really know all of the stuff at once. You can just move along and maybe understand them later. And I hope we will see the stuff. So we have C, char, or char, whatever you wanna say. Um, so yeah, you also need to take a look at the type and C equivalent. So I was missing to um, point out that this column is C equivalent, and this and you already know this is a description. That is non-trivial. Um, uh, um, that is trivial, I should say. But yeah, whatever. Um, so C sort means sort. Um, so it also says that uh, so if you don't know what the ABI means, that means uh, application binary interface. Application binary interface. Yeah, that is that's the full form. Yeah. Um, so it is done for the compatibility with C. Um, and C sort, that is equivalent with sort. CU sort, U means again unsigned sort. So you have all of this stuff, and I don't think you'll be using this very often. But you can also see C in front of all of this stuff to point out that these are just C equivalents of data structure or data type, I should say, that is compatible with the ABI of C. Anyways, so we have F16, that is float 16. Uh, we have 16-bit floating point, 10-bit mantissa. Okay, I do not know what this means. Anyways, we will look into it. We have F32, that means floating point, 32 bits. 64 is also equivalent to double. We have F80 and we have F128. We have bool, true or false, any opaque. Okay, so that would be equivalent to C void, used for type erased pointer. Okay, so we have void, always the value of void, no return. We have no equivalent to C. The type of break, continue, return, unreachable, and while. We have type, no equivalent. The type of types, an error, an error code, compile time, int, only allowed for comp time, known values. The type of integer, literals. So this should be related to comp time uh, that we had saw in the very first page of Jig. This one, comp time. Okay, now so we have primitive values. So true, false, that would be bool, null is to set an optional type to null, optional type. Okay, maybe we'll see something like something with equivalent to Rust. We just see that. Uh, and we have undefined used to leave a value on unspecified. So where do we get the optionals type? Do we see somewhere down the line? We should, but okay, opaque. Do we have optionals? Okay, is very down the line. Maybe we'll see about those, or maybe let's take a look at it. I don't know. Um, so we have optional type, we have normal int I32 that is signed 32 bit. We have this value, and we have integer, and we have question mark optional integer. So what that really means. One area that Jig provides safety without compromising efficiency or readability is with the optional type. The question mark symbolizes the optional type. You can convert a type to an optional type by putting a question mark in front of it like this. Maybe if you have used something like Dart language, maybe it's Flutter. I think if you have used a Dart, it certainly is with Flutter, because I don't really know what other stuff you will be using the Dart language for. It is highly specified there. But anyways, instead of integer, let's talk about pointers. So we are not really in the pointer zone, so I don't know if we should go along that line. Maybe we should take a step back and just follow the normal progression that we were having. Okay. Ah. So I think I have to drink a little bit of water. Mm. Okay. So what do we have here? So we have string literals and Unicode code point literals. String literals are constant single item pointer. Sorry. String literal are constant single item pointers to null terminated byte array. I hope you guys know what pointers mean, but if you don't know, do we get another page? I don't know. Open export layers. Uh-huh. Yeah. I don't know how we are supposed to use it now. Uh, Further we got no. Let's do a 5,000. 5,000. I think that's enough. Maybe. Fuck. Sorry for the language. I don't really know how to use. Okay. Uh, 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 this is a little tricky. But anyways, so let's talk about pointers. Mm, no, then no. Uh, and with yeah, suppose it should be fine. So we are talking about pointers. So maybe I should use pencil. Yeah. Okay. So we are talking about pointers. So if you have ever seen this symbol, something uh, similar to it, that means pointer. So in a way, it really means that if you have a value, let's say a equals to 1, now in a way you can do is b equals to a, and I'm not really writing a specific syntax here, but I'm trying to give a general definition of what a pointer is. So in a way, normally if you do something like this, most of the languages would do is a is 1, so it just copies the value of 1 and then puts, maybe we should build a memory diagram to maybe a stack. um, so this is a stack and this is a stack pointer. If you don't know this, then it's just fine. I will tell you. So normally when you are running a program, so it will be in different section of your memory. But normally while you are executing a program, and if you have ever written a I don't know, maybe a assembly language, then you probably know what a stack pointer is. But anyways, so while writing a program, we have normally we use stack pointer and registers with the program and heaps, but majorly we use normally we would use stack pointer and registers. But anyways, in stack pointer we have a stack and we have stack pointer. Stack pointer just follows the progression, like we have a memory address here, something no if I'm giving example, then maybe I should give the correct example, because normally the stack pointer is at the top of your um, stack. So normally let's say it's a 32-bit machine, so one would be a 4-bit value, because this is a hex one. Maybe I should a little bit dumb down a little bit of information, because maybe I'm giving a little too in a little bit too much of data here. Maybe that would be a problem. But anyways, uh, just try to understand the simple context of it. You don't have to know a lot what I'm saying here. But anyways, so you have one and you put it here, then you move your stack pointer down here, and now we have a value that is b, and you put the value a equals to 1. So the stack pointer uh, would be something like um, okay, I have a value here 1. Now uh, and this is not address, okay. Address also would be something like that, like this, but we are having a value up here, and we decrease it by, let's say, 4 byte, and because we are supposing this to be a 32-bit machine anyways. And in that we also, sorry, write something like f, uh, okay, maybe this shouldn't be f probably should be 0 0 0 f, because 0 means positive. uh, 0 0 0, maybe 1, not f, okay, 1. So yeah, so this says 1, and we are copying the value and making a space into the memory. But since the value is same, we don't really need to put the value in another location. And for now it might be just um, a single value, because it wouldn't really matter if um, you are using a pointer here, or a copy, because this is just an integer. You would need the same amount of memory. But let's suppose this is some very complex thing, you know where let's suppose it is a very complex struct, and if you don't know struct, let's suppose that it's like an object. If you have used any kind of object oriented language, it is not the same, but you can assume that it is very similar to that, if it helps you to understand that. So it wouldn't really be just 4 byte value, because this box can only hold 4 byte of value. So this would supposedly mean that it would take like 3 of these. And now if you're trying to do something like this, isn't 1 now anymore, this is some kind of a is some kind of complex value. Now you are writing p equals to a. Now most of the language would try to just copy the value and put it into the, let's say, the stack pointer. Now we need to make extra 2 spaces up here just to use the same value up here. That is, we can just write something, it doesn't matter right now. We just making an expression up here. So we'd have to copy all of this data that is same, that maybe static or dynamic, it doesn't really matter. So for that we can just do is, so normally how the program would work is that it would know the top of the starting address. um so let's say o x f f f f. Now if we try to do this, then it would copy all of that. What if we try to do something like b equals to a pointer of a, then it would just copy the starting address of that value. So it would be